Hey guys, this is Mike, and this is part 6 of the Connect Me video series. So, last time pretty much did some graphics, animation listener. So, over the week, I just a little bit worked on more of the graphics stuff here. I made a new pack. This was the old one, the grid, and then these. Here's a new one. I decided to go for each cell having its own thing instead of a huge grid square thing here. I was working on these. So these are the old graphics. All I did was put on highlights over here and then a shade on the bottom side here to make them look a little not so flat. What else did I do? I changed the width to 450 and set the color, background color, to dark. Cell, set the padding. I changed the padding to be based on the width sometime later. Let's see, check color, change the color of the what do you call it, alternating like dark thing, padding. Yeah, replace the grid behind the thing. So all just UI stuff here. The only difference in the actual logic stuff is that I actually made this level factory now. I'm not going to make files for every puzzle. I'm going to just hard code it into here. So here you can see red, green, blue, 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 red, blue, and this is level 1. So yeah, it's just going to be that. This is also just for me. I'm going to take this out later. This is just a screenshot class. Let's see, level data. This is just the for the level factory. This holds two things right now: the grid int array and the minimum number of moves. I have been trying to get the minimum number of moves working, but while I was trying to make a video out of it, I was just I thought it was pretty bad. The video when I was trying to make the algorithm for checking if the grid was finished. Here the check, where is it? Is finished. This should not have been hard, but it took a while for me to figure that out. But for now, this is what it looks like. Again, this is not final. This might be prone to change. I've been trying to come up with some kind of design here. So far, something that looks slightly like this is what I have planned out so far. I'm not sure what to do about the number of moves that you've made so far. Also, to show you how many stars you're going to get per number of moves that you've already done, so stuff like that. And I'm probably going to have a header up here, just like with regular apps, with the back arrow, and this one's just going to be to reset. And then the title, and then I don't know if I'm going to put the stars that you have up here. Yeah, I'm still working on that. But let's see. Finished. So anyway, while that I was just working on that, this is mostly just UI stuff over the weekend. I just wanted to update you guys, and I've also worked on the minimum number of moves finder. So if I run this, this is just in swing because I'm not going to actually use this in the Android app. I don't want to have to find the minimum number of moves in the actual Android game itself, so I put it in this utils. I guess you could say this could be on a puzzle maker, but I'm using it mostly just to find the minimum number of moves. And I could show you, I'm just going to show you what I did to do that. Where is it? So this is pretty much exactly the same as the one in the Android version, except it's Y flipped inverted because in Java 2D Y down, unlike in OpenGL. Let's see, check finish, pretty much the same thing, use BFS. Here we go, get minimum number of moves. So this one took me a while. The basic point is that you have to check brute force every single swap permutation. So here you have to check these two, and then these two, and these two, swap these, and then you just go down the list. Also, don't forget the verticals, and then so that sort of evolves into like this tree thing. So visually it looks something like this. Let's see, so you got your one, let's see, so you got your one thing at the top, and then you do like all your swaps. In this case, a 4x4 would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then vertical, that's 24. That's 24 different swaps on one move. So all the way here, and this is 24 of them. And then, of course, if you want to do two moves, that's another 24 per children. So 24 of those nodes, and then going down here, 24. So basically, the amount of permutations that you're checking increases exponentially here. So if I'm checking down 5 levels of 5 moves from the top, that's 24 to the 5 to the power of 5. So that is a lot of moves to check, and it shows because when I run this thing, checking if it's the minimum number of moves, it takes quite a while. And I've timed it over here, long start, and then at the end, where is it? Oh, here, print number of permutations checked, minimum number of moves to solve, and total time it took to get there. So I can try it now. I'll set debug to true, and I'll run it. So here it's calculating. As you can see, it's lagging because it's taking its sweet time trying to figure it out. There we go. Finished in 8.5 seconds. It says the minimum number of moves is 5, and it checked 2.3 million different permutations. And it also goes backwards. I did a node tree. So again, using this, let's say I went down the tree and I found out that this is a solved puzzle. So it'll go back up the tree and it'll find out the path it took to get back to the root. And yeah, so this is 5 moves going all the way down to the solved puzzle. And that's how it pretty much works. Just brute force your way down the tree, every possible permutation down the tree. So here you can see the root. This is the finished, or is it? No, this is the starting node, and then it goes down here all the way to the finished node. I didn't include the actual leaf node at the bottom. But anyway, so this is the starting node. Green, green, red, green, stuff like that. And then it goes down the tree because I have pointers for each node to the previous node and then all the children node under it. So to finish this puzzle, the next node says green, green, red, green, green, red, green, green. So it switched these two. That's one move, and then over here, green, 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 red. So it switched these two, and then red, green, blue, red. It switched these two, and red, green, red, red, blue. It switched these two, and then I forgot to put the final leaf node, but it's pretty obvious what the last move here is, which is that. So that's 5 moves to solve that puzzle. So I don't think I would have ever gotten that. Oh, I I should turn that thing off because it takes a while. You saw it was 8.5 seconds just for a 4x4 for checking 5 moves. So I would probably have never guessed the 5 move limit for this. I would just, oh wow, messed up there. Yeah, I would have friggin', oh wait, I finished it before? Best is 14. Not sure what I did there. Oh, I did that. 9 moves. So that would have been probably my best. I would have never... Dude, getting the 5 is ridiculous. How did I do that? The 5... Oh, wait. It's this one, then this one. Then... This one, and this one. That's 5 moves. That's crazy. So, I did test it multiple times. It should work. I didn't actually like go through and see if it fails at some point. I just assume it's gonna work because it seems like it works. Anyway, so I'll just go through the get minimum number of moves method. And yeah, that's gonna be it for this video. This is just an update. So get minimum number of moves. First of all, I already showed you the diagram of how it works. It just brute forces. It checks every single swap over here. So it checks this swap, this swap, this swap. So that's 3, 6, 9, 12 for the horizontal, and then the 12 for the vertical. So like I said, that's 24 permutations for the first swap for a 4x4, and then obviously the next level is going to be 100 or 24 times 24. Let's see. So I pretty much did the visited again because this is mostly for this is actually a serialization. What I needed to do was keep track of which which grids I've already done, so that I don't double check multiple grids. So for example, if I switch this, these two are exactly the same because I'm just switching 2 greens. So I don't check the second one because it's just a copy of the first one. So what I basically do is I serialize the grid here into a character string or array, which is basically just this, like R, G, G, R, B, whatever, just a bunch of those characters. And I put them in a set so I don't have more than one of them. And here's the node class that I had to make. So node is pretty simple. It just has a reference to the previous node or the parent node. So every node has like this one. The previous would be its parent node up here. And it also has a list of next nodes, which is the children nodes. So technically for a 4x4, every node would have 24 children in the next level. So this list should be of size 24. It also holds data, which right now is just the serialized version of the grid, which is a character array. And yeah, that's pretty much it. So I do BFS here again. I use a queue. Serialize the grid and deserialize it back into the cell array. So queue, add that first, and again BFS while the queue is not empty. I do the same thing. Grab the queue, grab from the queue, serialize it or deserialize it, and then I check to see if I've already visited that deserialized grid, so I don't have to check it. And if I haven't checked it already, I'll add it to the list that I've already checked and create a new node here with that serialization and add it to the next node. Also make sure I set the parent node. So that's pretty much just creating another node and hooking it up to whatever the current node is, which is what I took off of the queue. So q.add number of permutations plus plus, because that's another permutation to check. And I also have to check if it's finished at this point. And yeah, so I stop the timer, do all the stuff, print out the array, and then I can go backwards using just a bunch of previous, because every node has a reference to the previous node, its parent node. So I just go, once I find it, I just go right back up the tree, all the way to the root, and from there I can actually count how many steps it took to get to the root. So 1, 2, 3, 4 would be 4 moves. And along the way I also print out. So let's see, yeah, that's pretty much it. I swap, this is a vertical swap, right, row plus plus. So this pretty much swaps all the verticals. So this one, all 12 of them in this case. And I also have to remember to swap back so I don't change the grid. And then I do the same thing for horizontal. And this is another 12 swaps across the board that it checks, and pretty much the same thing. So yeah, if it didn't find it, it'll just return -1 as the minimum number of moves. And hopefully it actually found the minimum number of moves. I don't know how it doesn't, because this looks like it would work since it checks all of your permutations. Just to give you an example of how long it actually takes, I'm going to create just one larger array. Where is the array here? So I'm going to make a 4x5. There you go, and I am going to show you, and I'm going to set the debug to true so it tries to figure it out, see how long this takes. So while this is running, I'm just going to show you the level factory that I made real quick. Well, I already showed it, actually. Yeah, this is just a level factory. It's simple. Place state. All I do is get the level data from level factory.getLevel, and that just do a switch on these. And I set the grid, and I got the minimum number of moves. I could put that in here. Min moves. So I could just do that. Min moves is equal to data.get min moves. I don't have a use for it yet because I'm still trying to figure out the graphics stuff so far. Again, this not sure what to do here. I've been thinking about it, but see if this is done. It's not done yet. Wow. Okay. And this is just adding an extra column, by the way. Just one extra column. So if I have to make like puzzles that are 5x5, 6x6, I'm gonna have to sit here and wait for this thing to run. I tried to make optimizations to make the thing faster, but I really can't do too much since there are so many permutations to check. And since I've added one row or one column over here, the number of swaps it has to check again increases. So instead of the 4x4, which is 24 children per node, it's, let's see, 1, 2, 3, 4 times 4 is 16. 1, 2, 3, 4, 4 times 16, 1, 2, 3 times 5, it's 15. So that's 31 swaps for this thing. So each node has 31 children. And not only that, it probably takes more than 5 moves to solve. So let's say it takes 6 moves to solve. That's going to be 31 to the 6. That is a lot. It's not done solving it yet. Anyone? Does anyone know what 31 to the 6 is? Probably a large number. And it's not done yet. Holy crap. Go faster. I try to make it faster by using a set and serializing. Maybe the serialize is not really necessary. I could just use a double for loop to check if it's already there, but I'm not sure. Still not done. It's not responding right now. Oh my god. What happened here? How many moves is this thing checking? Let's try to figure it out ourselves. It looks like it should be like 5 or 6 moves, maybe. Move this here, here. Okay, this looks freaking just one here, 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 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 moves? No way. 12 moves? No way. The more moves it takes to find the minimum number of moves, the more exponential the amount of permutations it has to check. So again, if it's 7 moves minimum, then it's checking 31 to the 7, which is ridiculous. If it's 8 minimum moves, 31 to the 8 different permutations. Oh, that gets large real fast. It's taking a long time. It's taking way too long. Uh-oh. So I'm just gonna wait here and show you guys later. I'll just cut this part out. Okay, we're back. And apparently, I have a garbage collection overhead limit exceeded. I've made too many. Oh, I added too many to the queue. I ran out of memory. I actually ran out of memory. Oh man, that's not good. Obviously, that's not good. And this is for a 4x5. Damn. If I make this simpler, one here, one here. I'll make this a 2, 2, 2. That should be way simpler. Hopefully, let's try running this. I mean, I think I could solve it myself. 1, 2, 3, 4, 6 moves, probably. Oh man, even this one's taking a long time. The 4x4, oh, it figured it out. Nice. 5 moves to solve. It checked 5.9 million permutations. Took 28 seconds. Holy crap. 5 moves to finish this thing. Let's just figure this out. Green, 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 blue, green, red, red, blue, blue, red, blue, green, blue, red. Oh wait, that's the starting one. My bad. So finish it. This one. Then this one. And then this one. And then this one. Did I do something wrong? I don't see the obvious move. Oh, this one. So that's 5 moves minimum. Again, something I would probably never figure out. So that makes me want to rethink my star system. Because, for real, giving 4 stars to get the minimum number of moves is going to be ridiculous. I mean, are any of you guys ever going to figure out the 5 move combination for that one? I sure can't. So this was the puzzle. 5 moves. was what was it? It was this. Oh man, I didn't even do it. 6 moves. I don't remember what it was. Oh no. Here. Oh no, there it is. Okay, figured it out. So yeah, that's it for this video. I'll just push everything, and thanks for watching.